All right, we're going to try a little bit more substitution to solve some systems of equations. Not necessarily linear this time. So first system of equations has a quadratic equation and a linear equation. We're supposed to solve them together. So substitution is still a method that works. I would probably get y by itself in one of the equations. Conveniently it is for both. So if y is equal to 8x, what I'll do with this 8x is I'm going to substitute it for y in the other equation. That would give me 8x is equal to x squared plus 6x. Because it's a quadratic equation in terms of x, I'm going to set it equal to 0 by subtracting 8x from both sides. And then I'd factor and solve, use the quadratic formula and solve whatever it might be. So this one's a pretty easy to factor. Factor out x and I'm left with x minus 2. So zero product property, my zeros must be at 0 and at 2. Now those are the two x values that work. So there's actually going to be two ordered pairs, two coordinate pairs that are solutions to this particular system. So I'm going to write out 0 comma something and 2 comma something. And I'm going to plug those back into probably the second equation, which gives me y just by plugging in x nice and easy. So if I plug in 0, 8 times 0 is 0, so 0, 0 is going to be one of the ordered pair solutions. And then if I plug in 2, 8 times 2 is 16, so 2 16 is going to be that other ordered pair solution. Okay. Now this next pair of equations, I've got 2x plus 2y equals 100 and xy equals 300. What I want you to think about is if you had to find, like, if you were told, hey, the area of a rectangle is 300 feet, and the perimeter of that same rectangle was 100 feet. Well, this would be a system of equations that would model that situation. If you want to imagine drawing a rectangle and calling it x times y, okay? So if I want to find the perimeter, I'm going to add up the four sides. So there's going to be two x's, these two sides, and there's going to be two y's. When I add the two x's and the two y's, I get 100 feet, let's say, if that was the unit label out, okay? And if I wanted to find the area of a rectangle, I take the length times the width, or the x times the y. So this is a system that could model a situation kind of like that one, okay? Now, substitution would be the way to solve something like this as well. And maybe graphing, there's other things that you might try, but I would probably go with substitution first. You got some options as far as which variable you want to get by itself. Your textbook does it a certain way. I might recommend doing this. I'm going to show a rational equation trick. I'm going to get y by itself in the second equation and say that y is equal to 300 divided by x. So I just divided both sides by x. Okay. Substitute that into the other equation for y. So we're going to take this and put it there. So we're going to have 2x plus 2 times 300 over x is equal to 100. Now, I got a rational equation now because I just put x in the denominator of a fraction. Those are sometimes difficult to solve. So what I'm going to do is I'm going to multiply everything by a least common denominator, which in this case is just x. It's the only denominator I see. So if I were to multiply the whole equation by x, x times 2x is 2x squared. X times 2 times 300 divided by x is going to cancel the x's. X over x cancels. 2 times 300 is going to be 600. And then x times the 100 over there, it's going to equal 100x. So now again, I've got an equation. In terms of x, it's quadratic because there's an x squared in it. I'm going to set it equal to 0 and solve using my quadratic method. So if I subtract 100x from both sides, and 2x squared minus 100x plus 600 is equal to 0. Okay. Now I'm going to save you the time of doing the quadratic formula to solve that one. That's not one that's factorable. Quadratic formula would be the way to go. And again, for the sake of time and videos, I'll trust that you know how to do that. I will show you graphically what that might look like. So if I were to graph that expression, it would look like this green curve right here. And it would actually have two intersections. Again, I don't know how good the video quality is, but there'd be two intersections here. One's at about almost 7, the other one's a little bit more than 43. So if I were to find the ordered pair solutions to the equation that I was working with, if I can bring that back, I would take that, those two numbers, the 43 number, the almost 7 number, I'd plug them back in here, and I'd solve for the corresponding y values to get my two ordered pairs. That would be the two solutions to that particular system of equations. So that's solving a couple more systems of equations using substitution.